Okay, just checking to make sure the stream is working. And how on earth do I find streams? Okay. Just checking. I'm just checking on my phone to see if I'm actually... what's going on here? Do we have anything happening here? It doesn't really look like it. I'm going to... So apparently we're streaming. Let's check the YouTube machine. And live streaming. No, apparently, according to this, we're live. And let's see what's happening here. Ah, look at that. No, video is unavailable. Now, I've got no idea what that actually means. No. Okay, let's hit refresh. So it says we're live. And it's been going for 2 minutes 40. Okay, I can only assume that it's buffering, so let's push on regardless. Okay, so this tutorial, this live stream, I am going to just work through a workflow of creating a basic space shooter, 2D space shooter game in Godot. I've got no idea how far we'll get, but let's see how far we can go. So I'll try and sort of explain as much as I can as I go along. So what we have is I've loaded up the Godot engine and I've created a project called Super Defender. We don't have any scenes. There's as you can see on the side here, the file system, nothing's been created. So let us go ahead and create our first scene. Let's create a player. Now the player is going to be a spaceship. So what I'm sort of envisioning is a sort of a Space Invaders type game, but we'll sort of probably just end up winging it as we go along. So let's create our player, and for our player I'll just go back a bit slower. So we go to create a custom node, and the node we're going to use is an Area 2D. So Area 2D is a really quite a handy node or scene, and the reason for that is that they can detect things. So I'm going to use the word collision, but they can detect other areas entering their area, and that's really handy for determining things such as a bullet hitting a spaceship or a spaceship hitting another spaceship. So that's going to come in really handy. So we've created an Area 2D. What I like to do is I like to rename it something. So let's rename it player and then enter. Now I've got a little warning sign there. So what that's telling us, if we have a look there, it's saying this node has no shape, so it cannot collide or interact with other objects. So let's add a shape to it. But before that, let's add a sprite to it. So we're going to add a child node, and we're going to search for sprite. So we've got a sprite node, and we've got a player node in our, we've got a player node, area 2D node in our player scene. So what we have over here, we have an inspector, and this has got all the properties. So if you have a look, when we're highlighted the sprite, the properties are what are available to the sprite. So we've got texture, whereas when we go to the area properties, we don't have things such as textures because it's an area. We've got things such as, you know, gravity velocities and priorities and monitoring and yada yada yada. So let's go to the sprite. Now, as you can see here, all we've got, the only sprite we've got is the default Godot icon. And what we're actually going to be doing is we're pretty much going to be using that until we can get some assets. So it's going to be a sort of a placeholder asset, as it were. So let's add the icon. So that is now the texture for our player sprite, player scene. And let's go ahead and save this. So I'm going to go Control S, and now Godot gives you a lot of freedom as to how you want to organize things. So I like to, and this is not necessarily the best way, but this is just the way that we're going to do it today. I'm going to create a folder called Scenes, and in Scenes we're going to create, we're going to save the player scene. So I'm going to save that. Okay, so let's go back to this, and we're going to, remember it was giving us that warning about adding a shape, a collision shape. So let's add a collision shape 2D. Now, what we're going to do is I'm just going to delete that. And we're going to do this later because I think we're putting the cart before the horse here. Let's just work on the basic player sort of movement and stuff like that. So what we're going to do is we're going to add a script, and you can either right click and go attach script, or we can click on that thing there. Okay, so I like to right click, gives my fingers exercise. So we're going to attach a script, and same thing again, the path is going to be in a folder which we are going to call scripts. Oops, helps if I could spell scripts. Okay, now actually I've got no idea how I see if people are asking questions, and considering we've got no one watching, that's probably not a huge consideration at this point in time. So player script we're going to open, and we're going to create. So let's take this opportunity to have a look at the basics of a script. So we have the ready script. Now when this node enters the scene tree, so when it's called into the game, for want of a better word, the ready function is run. Okay, so what we're going to do, and it gets run once and then everything else happens. So we're not going to worry about that too much for the time being, but we are going to worry about another function which is very important, called the physics processes delta. Okay, so this process gets run once, gets run at the frame rate. So it gets run the number of times of the frame rate per second. So if the frame rate is 60, it gets run 60 times per second. So that's really important because we want some constant way we can control things in games. So in normal applications, we usually just want to hammer through things as fast as we can to crunch those numbers. In a game, that would be not what we want, because if that was the case, creatures may move faster on a computer with a faster clock speed than a computer with a slower clock speed. So the physics process is a constant sort of rate of processing this method or this function. Okay, again, don't worry if none of this makes sense. It'll make sense. But speaking of frame rates and stuff like that, it's probably a good idea now to I'm just going to click run the play the scene. Okay, so if I click that, it plays the whole game. That's just going to play the scene. So let's play the scene and see what happens. And we've got an error. Okay, we've got an error because we don't have anything in there. It really needs, okay, it really needs something in there. So let's just comment it out for the time being because it's not doing anything. So you can comment by a hash or a pound or whatever you want to call it. And so there we go. There's our player. And there's our screen. Now, I'm thinking for a Space Invader-y, droppy downy sort of game, it would be nicer if we had a portrait-y type screen layout. And so let's have a look at that. So we'll go to project settings, window maybe. Yes, okay. So let's say, I don't know, 420 by 640 maybe, and go close. So now when we click play the scene, the window is now sort of like that, and I think that'd be good because what I'm thinking is we have our character there shooting up, have enemies dropping down, dropping bombs, you know. I think that's the way I'd like to have it. Okay. So let's get back to our physics process. So the physics process gets run once every so many times per second. Gets run not once per second, but however many times we've specified the frame rate to be. So it's going to be a pretty boring game if the player can't do much. So let's get the player to do something. And we're going to get some input from the keyboard. And we are then going to use that input to move the character. So if we listen to what I said, we're going to get some input from the keyboard. So we're going to have to set up some key bindings. Now Godot is really good like that. So if we go to project settings, and we go to input map, what we can do here is I can create an action, and let's call this button left. Okay. Actually, no, let's use lowercase button. Everything else seems to be lowercase. And so now we go add. So what that's saying is that there's an action called button left, and we can now assign either a key, a joystick button, joy axis, or a mouse button. So that's really cool. So that means that you can have a game which can be controlled by, say, cursor keys or the WASD, and it can also be controlled by joysticks, whatever you want. So this is really kind of cool. So let's add a key though. So let's say press a key. So I'm going to press the left arrow, and then I'm going to click OK. So what we're going to do as well is let's add another key for button left, and this time let's add the key A. Okay, let's add another action, and we're going to call this one button, and you guessed it, button right. Okay, so let's add that. So for button right, we are going to again go key, and it's going to be the right arrow. Okay, and oops, on the WASD side of things, let's go a D. Okay, and probably the final thing we're going to need for the time being is probably, well, that's probably about it that we need, isn't it? So getting back to our physics process. So remember, this is being continually run, and we want to try and figure out, we want our thing to do something to move it. So let's say if, and this is what we learned about if statements, input dot, I think it's is action pressed, button left. So you can see here it sort of brings up sort of context sort of suggestions. Button left, double click. Okay, so if action is pressed, button left, colon, then what are we going to do? Let's move our player. So so we're going to move the position. So position, and position relates to the position of this scene, the player scene. Position dot x, so this is the x positions on the x-axis, equals position minus, I don't know, let's minus 3. Okay, now what's happened here? What have I done wrong? I've done something wrong. Okay, so again my error is it should have been position x. Okay, so what that's saying is that when we push the left button, which in our case we've set up to be either the left arrow or the A button, we will set the position of our player to be equal to its current position minus 3 pixels. So that's what that's saying. Now that can also be written, actually I'll do that on the next bit. I'll show you another way you can write that positioning bit, changing the position. So now if, let's do it for the right button. If input dot is action pressed, the second one is action pressed button right, we have position. So now this is a position x. Now and this time we are going to say equals position dot x plus 3. Now, so let's run this and see what happens. So we're going to run this scene. It's very rare that things. Ooh, so now I'm pushing right and I'm pushing left. So we're actually moving the player left and right. Okay. So let's close that. Now I said there's another way you can write that. We could also write position x, if I write it like this, that is saying that position x is equal to itself plus 3. So let's see if that works. And so that does exactly the same thing as the previous thing. Now I'm just going to control Z because we're generally going to be doing things the long and the hard way during this sort of tutorial series, because it's just a bit of an easier way to, I think, consolidate what you've learned. Okay, rightio. So we've got that. Now, what the one other problem we're well, it's not really a problem, but when we run this, that is sort of up in that top corner, and that's because that position there is what we call 0, the origin, and so that's where that character is being put. So what we're going to do is let's drop this player into a world. Okay, so we're going to create a new scene. So let's create a new scene, and let's make this scene a scene 2D again. But let's call this Space Arena. I don't know, what should we call it? Let's call it, well, let's call it level 1. I don't know. Level 0, 0. Okay. Okay. So let's save this, and we're going to save this in scenes. So it's level, that's the level scene. So go save. Now, when I play this scene, not much happens. So what we're going to do is we are actually going to instance a scene. So you know how we've got the player scene? We are going to put that scene as a child of this level scene. Now you're probably thinking, well, what on earth are you doing that for? But it'll become sort of apparent. So that's our basic player, and it now exists here. The good thing about this is any change we make to our player will be propagated to its instance in this thing here. So I'll show you what I mean. Let's go back to our player, and, well, actually no, let's run our level 1 first. So we're going to play the scene, and I'm moving left and I'm moving right. That's all well and good. Now if I change the player, so I'm actually in the player scene, and let's speed this up. So let's make this 15. So when we go left, it is going to really hammer along pretty fast. And now we're going to go back to our player. No, we're going to go back to our level scene, and we play that. So when we go right, it's going at the normal speed. But watch what happens as we go left. It goes really fast. So how cool is that? So what that's saying is that this player that's instanced here, let's just say we had lots of different players, and in our level we might have, or just say that was an enemy or something like that. When we need to make a single change, we don't have to go and change every one of these. We just change the original scene, and that's really cool, and it's going to come really handy. So let's go back to our level though, and let's go to the 2D representation. I'm using the mouse wheelie button, well, I'm using the trackpad thing to pull out, and what we're going to do is we're going to move this. So I'm going to go to move mode, click that one, and we're going to move player, and let's place him or her there. So now when we run the scene, we have our player there, and that's looking more like a Space Invader-y type game, isn't it? Now the thing is, I've still got that ridiculously fast thing happening there. So let's go back to player and fix that. In fact, let's take this opportunity. So we're on the scene thingy. So let's go back to our script. Let's fix this, because let's just say that we're testing this, and we want to find out what a good speed is. What would really become a bit of a grind is if we said, well, do we want it to be 1? And then we'll have to change that one too, and then we do that, and then we have a look. And we have a look. Okay, so the reason why it's not down the bottom on this one is because I'm running the player scene, not the level scene. But for this purpose, we just want to see and what effect changing the speed does. So that's probably a bit slow. The problem is that every time I want to change the speed, I have to change both those values. So what would be really easy or nice is if we create a variable. So let's call this variable speed, and let's say that it's equal to 3. Now what we can do is we can put speed there. So what that's saying is position x is equal to its position minus the value of speed, which is defined up there. Okay, so now watch what happens. Let's play it on the level scene. So when we play that, it changes. Okay. Now we can take this one step further using Godot, and we can do an export variable. So if I type export, export variable, what will happen now is it creates what's called a script variable. So the speed can now be altered in the editor, and that's really cool. So let's just say that I wanted to change the speed to say 6. Now all I have to do is type 6, okay, while I've got a player thing selected, enter, let's run the scene, and now it's at 6. If I want to go back to 3 and run the scene, and now it's back to 3 pixels per tick. Okay, so that's kind of cool. I think it's kind of cool anyway. Okay, rightio. So what we're going to do now is we're going to try and run the game, and you'll see an error will appear. So if I go play, it says no main scene has been ever defined. Select one. So what that's saying is it's saying we've got two. I'm going to cancel this. It's saying we've got 2 scenes here, but which one is the actual game scene? So if we were to sort of put this on the internet and let people download it, and they wanted to play it, when they load up the program, the machine is not going to know which of these to run. So we need to specify that. So we can either go select and do it, but let's do it the hard way. We go project settings, general, application, no, config, there we go. Run is what we need. Main scene, so we click that one. And let's call the main scene level 0, 0. Okay, so we go close. So now when we hit the game, there we have our little character there, so he's moving along. Now one of the things that we want to do is we want to limit the motion a little bit. So if you have a look, we can go sailing off the screen there, and that's probably not the most fun thing to do. So let's see how we can limit it. So we can probably limit it by saying if the input action pressed is button left and it's not too far to the left, let it move. Okay, so now we could say, so and position X is greater than, and let's just say 32, then we move. And so we can also say the same thing here. And position dot X is less than, so what did we say it was? How big did we say it was? What do I click there? I've clicked some weird thing. Okay, is less than, so we said it was 420 wide minus 32. So what I'm saying here is, so we can, if we push the right button and the position is less than 420, because 420 is the edge of the screen, minus 32 to give it like a nice little margin, then it will move right. Otherwise it won't. So let's give this a whirl. So there we go. So it's locked there, and it's locked there. Okay. So I actually physically cannot go any further than the sides there. So what we'll do, again, let's create a margin here. Let's create a variable. So variable left margin, or margin left equals 32. Sorry, I keep clicking the mouse trackpad and keeps doing something. And let's have variable margin right equals the size of the screen, the width of the screen, 420, minus margin left. Now I'll show you why I'm making it look ridiculously complicated like this. Okay, the reason for that is so let's go margin left margin right. So the reason why we're doing this is because what we want to say is that the margin, we assume that there's going to be some symmetry. So that if we've got 32 on one side, we sort of want the margin to be 32 on the other side. Okay, so I'll just show you something. So let's play the game. And so stops. Now let's just say we want a bit more of a buffer. So let's say we want the margin to be 64 pixels. We go that one, so bang and bang. So we see we've got some symmetry there, and that means that all I have to do is update that one value rather than having to update the margin left and the margin right. So we'll do that. Now what else would we like our spaceship to do? I reckon we would love it to shoot something. So I keep hitting that. Don't you hate these trackpads? So if we wanted to shoot, we're going to have to assign a button for shoot or fire. So let's go to project settings, input map, and let's go action, and we'll go button. You want fire or shoot? Fire, button, shoot. Yeah, button fire. Yeah, go button fire. And then we go add. And we'll go key, and let's give it the space bar. Okay. And that means it can be used with the WASD or the cursor keys. So if input is, now we're going to do something different, and we're going to use is just pressed. Okay, and let's have a little bit of a discussion about that. So as I said, what's happening in this method, every 60th of a second, because its frame rate is 60, this is being processed. So what that means is that when we're holding down the left button, every 60th of a second, the X position is changing by 3 pixels to the left. But if we were to have this input here as action pressed, unless we held the button, the fire button down for exactly 1/60th of a second, it will actually trigger every time. So it would end up with a really fast, rapid, repeating shot. In fact, let's do that. Let's do it the wrong way. Let's do it the wrong way. So what we're going to do is, what we're going to learn now is a great useful tip for debugging, and that is using the print. So what print does is, print doesn't actually affect the game, but it gives us some output here. Okay, so let's go bang. So what that's saying is, and I'm just going to change this to action pressed. So action pressed, so if action pressed is button fire, print the word bang, and we better put a closer thing there. So when we run this, watch what happens here. So that's where the printing should occur. So I'm just going to do this. So I'm going to press, see how it's going, and like I can scroll right up there. So it's shot a lot of bullets by me just pushing the space bar. So I'm going to do it again, and I'm going to quickly tap the space bar. So even those slight taps, so let's clear that again. So even the slight taps shoot, I don't know, whatever that is, 10 times, 9 times. So we don't really want that. So what we want to do is we're going to change this to is action just pressed, and that means that has the action been pressed, and if it's been pressed, it will trigger it, but it needs to be released and then pressed for it to be triggered again. So it's probably easier if I just play the scene now. So if I play the scene, I'm holding it down, releasing, holding down, releasing. So that would be I think that would be, for this game in particular, that would be a better mechanic to use, okay, because we're going to be firing rockets. Maybe if we're firing a laser beam or something like that, then definitely having is action pressed might be the better way to go. So bang is not a great, is not that exciting a thing, because your player is never really going to see this output unless they're running on a debug mode or something like that. So what we're going to do is we need to get it to shoot a rocket. And to do that, we need to create our rocket or bullet or whatever you want to call it. So let's create a new scene. So go new scene. And again, let's have it as an area 2D. And we're going to call this projectile. Projectile. Okay, so let's save that. And we'll save it on our scene, so we make sure we're in the scenes. And we go save. Let's see if anyone started watching this. Nope, no one's watching. Okay. And so we've got projectile. And it's saved. And what we want to do is let's add a sprite to it. So add a child. And let's add make sure it's type sprite. And again, we've only got one sprite to choose from, so we'll use that. Right, no, sorry, my mistake. So click on sprite and go to texture. I was wondering why that wasn't working, and load, and then load in the icon. Okay, so let's add a script to this. So let's attach a script, and we'll go to, now remember, we don't want to save it in the scenes, we want to save it in our script, folder. So let's go scripts, and we'll open it there. Okay. So what we're going to do is let's create the file, and let's give it a speed. So variable speed. Okay, so what we're going to do is we're basically going to give a default speed of 6. Now we'll be getting to a bit of a quirk about the Godot coordinate system. It's not really a quirk, but for the maths people among you, it will become a little bit tricky, and it usually always gets me. So what we want to do is we're going to add a physics process. So physics process delta, and what we're going to get it to do is we sort of want it to move up the screen. Okay, So again, we're going to go position, but this time instead of X, whoops, not that. Instead of X, we're going to go Y. Now, so if we wanted to go up, how the coordinate system works in Godot and other game systems is the horizontal axis, the x-axis, obviously to the left of the origin is going to be a negative, and to the right is going to be a positive. But above the origin, in the Cartesian plane, is actually getting more positive. In the Godot system, going up is actually going negative, and going down is going positive. So if we're going to go up, we need to subtract a value. So equals position y, no, y minus, wait, no, we've got our speed variable, don't we? Speed. Okay. In fact, what we're going to do, let's change this to plus speed, and let's give the speed a negative value. Now, the reason for this is later on, we might want to use the same projectile to be going back down. So, as you know from maths, you add a negative, it's a negative, you add a positive, it's a positive. So what that means is that if we're going to be shooting upwards, we're going to want a negative speed. So it'll go from, I don't know, 100 to 94 to 88 if we're going with that speed. Or if we were with a positive number, we would then be going downwards. Okay, so again, that's not going to make much sense, but it will make some sense a bit later when we add bullets to the enemies and all that sort of stuff. Now, the other thing we want is we want to try and conserve as much process memory and processing power as possible. So there will be a point when we're shooting a bullet when it will leave the screen. Once it leaves the screen, it serves no real purpose. So at that stage, what we're going to do is we're going to show you how to destroy a scene or an object or a node or whatever you want to call it. So let's say if position dot y is greater than, let's say is greater than, no, less than 0, isn't it? So if is less than 0. Now this is really important, this command. It's Q3. So Q3 basically says destroy the, so in this case it'll be destroying the projectile and all its children. Okay, so let's have a look here and see what happens. So if we go play the scene, nothing really happens, and the reason why nothing happens is it started there and it went up. So let's go to our level scene and let's just instance this just so we can see, just so we can make sure, see what's happening basically. So let's open that and let's grab the projectile and let's put it there. So now when we run it, hopefully it should go up. Hopefully it does. There we go. Okay, so it goes up. Now let's just say that we want it to be shooting down. What we'd do is we would then change that value to or just not plus 6 to 6. Okay, so this is what I was blabbing on about earlier. So let's run the game. And so now it goes down. That was really hard to see. So let's change the position of this. So we'll move it up. So now when we play, remember we've got that positive 6 value, it goes down. Okay, so that's cool. That's working like it should. But we're going to delete this because obviously we don't just want random projectiles flying around the screen. What we want to do is we want that projectile to appear when the player shoots. So to do this, we are going to create a variable called Projectile instance, and it is going to be, we will load the scene. Now, for those of you who have done a little bit of this, you'll know that you can preload it and all that sort of stuff. As I said, this is not necessarily the best way to do it, but it's a nice way to get a handle on things. Once you get familiar, there's a lot of shortcuts, a lot of better ways you can do things. So, but what we're going to be doing is we're going to be loading the resource. We're going to be loading the scene and instancing it. So instance. Okay. So what this is doing is this is creating a variable which is referencing an instance of that scene. So what that means is we can do a lot of different things to that scene. So the first thing we're going to do is we're going to want that to have a speed to it. So let's say projectile instance. So now we're accessing the variable, and remember how we gave it that variable called speed. We can now change that variable. So let's just say that we want the speed of the bullet to be, remember going up, we want it to be a negative number. Let's just say we want it to be -1. Now, what we need to do is we need to also set the position of it, because remember at the moment if we instance it, it's going to be on the top right hand corner. So let's go position. Now the position we want it to be is basically a very similar position to our player, our spaceship. So position. So what that's saying is that the position of the projectile is the position of the character, of the player I should say, because we're inside the player node. Now you don't have to do this. I don't regularly do this, but for clarity's sake you can say self, and so that's just so when you're reading it you know that we're referring to the position of the self, which in this case is the player. So let's go ahead and add. So the other thing is it doesn't actually exist because it hasn't been added to the scene tree. In fact, let's do it the wrong way just so you can see what happens. So I'm going to play the scene. Now what you can notice here, so this is the scene tree, the dynamic scene tree. So we have a player, we've got a sprite. Now watch what happens when I do this. So where's our game? If I'm going to press space and nothing's happening, and the reason why nothing's happening is we're instancing the scene but it's not being added to the scene tree. So what we need to do that, we need to do a thing called add child, and that will then add it to the scene tree. But we don't really want to add it to the player, because if we add it to the player, strange things happen. So again, let's do it the wrong way first. So let's add child, and the child we're adding is this projectile instance. So now watch what happens. We're going to play it. So what we've got here, we've got our scene tree, and I'm going to push play, the fire button. Okay. See how a projectile was added. Okay. And another one was. Now we're adding all these projectiles, but watch what happens as I move left and right. It's moving, and it's disappearing. And the reason for that is, and as you can see, they're getting Q-freed there. So the reason why that's happening is because we're adding it to the child as a child of the player. Okay, which means that, remember from the earlier videos in the Discord, that when you add something as a child, anything that the parent does will affect it. So what we actually need is, we really need that projectile to exist at the same level as the player. So to do that, what we do is we use a command called get parent dot. Okay, so now when we play it, watch what happens when I push. So now we've just shot it and it moves independently of the player, and as you can see, it disappears when we get up to top, because in reference to the player, that is the 0 point, and that's what was disappearing there. So now what we can do is we can shoot a whole bunch of bullets there, bang 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 bang. Okay, but they're moving a bit slow, so what we can do, remember remember how we set the speed here, so we're actually affecting the speed. So if I comment this line out, then it is going to go to the default speed of 6. Now remember, 6 is actually going to be going downwards, so we better change that to -6. And it goes a lot faster. Now but if we go back to player and we take that out, that's then saying go to the projectile instance, which in this case is the projectile, and access its speed variable and set it to -1. So what we could do is we could make it 2. Let's see. So I'm hitting space, so that's a bit faster. But I think 6 is probably actually not a bad number, really, is it? Yeah, I mean that's probably not a bad. Actually, it might be a little too fast. Let's go 5. Okay, too easy. So we've created our player and our projectile. Okay, now what we're going to do is, because we're using temporary art, which is the Godot icon, what we can do is let's do something just to give it a bit more variety until we can get some better art. Let's go project instance. We're going to set the scale. Now the scale has both an X and a Y value, which means that we're going to use a vector 2. So a vector 2 is a way that we can access something that's got an X and a Y value. So let's make it a quarter of the size that it originally was. So we're applying scaling to the X and the Y value. So now when we play, we're shooting a very small little bullet there, and that, I don't know about you guys, but I think that looks pretty cool there. So so we've got our player, we've got a projectile. Do you know what we need now? We need some enemies. So let's create an enemy, and it's pretty much going to be the same sort of dealio. So I might move slightly faster on the enemy side of things, only because it's pretty much going to be the same as the projectile, really. So because we're not going to give it a great deal of AI or anything like that. So remember, we go scene, new scene, custom node, area 2D. Oh, remember, you want to go area 2D, not that area. That area is actually area 3D, and that's for 3D games. So area 2D, let's call it enemy. Actually, let's call it, we'll call it enemy. It's probably fine. It's generic enough. And let's give it a sprite. So let's give it a sprite, and as I said, we've only got one sprite we can use at the moment, and that is going to be the Godot icon. Okay, so let's have a look at this so far. Ooh, hasn't been saved, better save it. So we'll save it there, and there we go. So it's just sitting right there in the corner doing absolutely nothing because we need to program some logic into it. So create a script, go to our script. So I'm going fast because this is the same thing that we've done earlier on. Scripts, sprite, okay, create. Okay, so again, let's give it a speed. So variable speed. And let's give it a speed of, I don't know, let's give it a speed of 3. So that's going to be 3, obviously moving down. And let's give it a physics process delta. And let's say position dot y, because we're going to want it coming down, equals position dot y plus speed. Okay, so now when we run the scene, test the scene, it should come down like that. Okay, which is probably a bit fast for an alien. I mean, that's going to be really testing our reflexes. So why don't we give it a 0.5 speed and see how that looks. Okay, that's cool. We can work with that. Okay, so that's really cool. But if we go to our level, how are we gonna do this? So do we instance a whole bunch of enemies? So let's go enemy. So we could put one there. Let's go back up there, because remember, if I was to instance another enemy, it would actually be instance of a child of that enemy. So if I was to do that, it's sort of now, because it's a child of that one, if I move that one, they're both kind of going to move, which is not cool. So if that ever happens, see how it's now it's a child. All we do is we just bring it back up there, and now it's at the same level, so it can move. So if we play the game now, we have two things, and obviously they're not set up to do anything when we shoot them. They're coming down at us. But the problem is, I'm quite lazy. I don't really want to have to manually set all of those, because that'd be pretty tiresome for me, and you know, I'd have to do about a gazillion of them to make the game interesting. So let's delete these and let's create a spawner, because spawners are cool. They're very cool. So let's go for a new scene. Okay. And now this time, the spawner doesn't really need a great deal of sort of things with it. So we're going to use the most basic of nodes, and that is the node, just so not a node 2D, so not a node 2D or anything like that, just a node. And let's call this spawner enemy, and we'll save that, and we'll save it in the scene directory. And again, what we're going to be doing now is I will be slowing it back down a little bit. So we're going to go back into the scripts, open. Okay, now, so we're going to create. Now, the thing is, what we're going to want is we're going to want this spawner to spawn at a rate. Doesn't necessarily need to be a regular rate, but we want it to basically keep going up until some point. So to do that, we're going to add a child node, and it's a node we haven't looked at yet called a timer. Really cool, these timers. Okay. So what we're going to do now is we are going to create a reference for this timer. So, and I'll just show you. I'll show you. Actually, let's do it the wrong way first. No, let's just do it the right. No, yeah, let's do it the wrong way first. Let's do it the really hard way first. Okay. So we've got a thing called a timer there, and let's set it up. So timer, we're going to have. We're going to get the node. So that gets the node called timer. Because remember, the timer is a child of this node that we've got the script attached to. And we are going to do a thing called set. No, we're not. It's called wait time. Wait time. And we're going to give the wait time a variable. So to do that, we're going to use the random range, and the wait time is going to be any time from, I don't know, let's say 2 seconds. No, let's say, yeah, 2 seconds to 4 seconds. And then we're going to go get node. Oops, no, not get incoming connections. Get node timer start. So that's starting. That's starting the timer. Then what we're going to do is we're going to use a signal. We're going to connect up to a signal. So we're going to get the node. Now, as I said, we are doing this the hard way. Just keep doing that. Get node. We are doing this the hard way to show why we want to do it the easy way later. So, oops, timer. Okay, so what we're going to do is we're going to do a thing called connect. So we connect, and we are going to connect a signal that the timer is going to emit once it hits, once it's finished counting down, and that's called a timeout. So when the timeout signal is triggered, it is going to look at itself, and when I say self, I'm talking about the spawner enemy self, for a function called on timer time out. Now, I haven't created that function yet. So, but what that's saying is it's saying that when so I'm going to Control C to copy that. So what that's saying is that when the timeout is triggered, then call a function called on timer timeout. So let's do that. So function. So I've just pasted that. So we just created our first function, and we are going to say let's instance. Remember how we instanced the projectile a little bit earlier? Let's instance the enemy. Okay, so let's go variable enemy instance equals, remember, load, and again load, where are we, enemy scene, so the enemy scene there. And remember, the biggest mistake I always make is I don't put instance at it, and you get all kind of packed scene errors and all that sort of stuff. So we're instancing that, and let's set a position. Oh no, we need to go enemy instance position, don't we? Enemy instance position. And let's say its position is going to be, and we really only need the X position, don't we? X position equals rand range So let's give it a. So let's say, what did we say it was? 32 or something. The margin, wasn't it? 32. No. So let's just go back to player. So what we're trying to do now. So sorry, the margin was 64. Okay. So spawn an enemy. So we want it to spawn 64 pixels from the left to 420 minus 64. So we don't want it being in a part of the screen where the player can't shoot, is essentially what we're doing here. Okay, now we want the enemy to, let's add the child, but remember we probably want to add it to the parent. So add child, so we get node, we get parent. So get parent, add child, and it's going to be the enemy instance. Okay, now the thing is, so what we've done now is we've said get the node, when the timer times out, we are going to trigger this function here, which then creates the instance of the enemy at a random position up the top screen, because remember, when it gets instance, it's going to be instance at y equals 0. But what we want to do is let's now create a, so get node timer. Let's reset the wait time, and the reason why I want to do that, otherwise we'd end up with the same wait time that was created on that random range there. So let's just say that random range became, I don't know, 2.5. Every 2.5 seconds this is going to be called. So let's change that to rand range, and this just adds a bit more flavor to the game. So again, we want it between 2 and 4. Okay, so what we need to do is, when we play the game, nothing's going to happen because this hasn't been added to the scene tree yet. So let's add this one. So enemy spawner. And now to move that up, you can go control up arrow. We'll put that up. Doesn't really matter in this case. I just like spawners to be up the top. So now when we play, look what happens. And what we'll actually do is, so the enemies are being spawned in random positions, sort of at random times. And you can see that at random times because the gaps here between them are spaced differently. So it's a big gap, that's a little gap, that's a big gap, that's a big gap again, that's a smaller gap. So what we're doing is we're randomly generating these enemies that are falling. Okay, so that's pretty cool. But we can go a little bit further, and let's go to our spawner enemy, and let's just tidy things up. So I said, I was umming and ahhing earlier about which way we should do this, and I said, well, let's do it one way, and I said, no, let's do it the other way, and I said, no, let's just do it the hard way. So this way is correct, but there is an easier way to do it, and I'll just show you what happens. So let's just say that we had a couple of different timers, and let's just say that this timer we now call timer spawn. Okay, now when I play it, I get a whole bunch of errors, and so what that's saying is an invalid wait time on a null instance, and that's because get node timer no longer exists. So when we go to the local thing, because it's now called timer spawn. So this sort of stuff comes up quite a lot because, you know, oftentimes we're just belting code out off the top of our heads. So to make it a little bit easier for ourselves, what we want to do is we want to assign a reference to that node there. So let's go Now, you need to use a special command, and it's called onReady. And the reason for that is it waits till everything's been attached before it starts checking these variables. Otherwise, it'll check the variable, and that may not have had a chance to enter the scene tree or be spawned or whatever. So onReady variable equals, and let's call it timer. No, it doesn't equal timer equals. Now we can either say get node. So I'm going to do it two ways. So we can say get node timer spawn. And now what we can do is we can just use that variable. So we use the variable called timer. Actually, what I'm going to do, I'm going to Control C to copy that, and then I'm just going to paste this because I'm so lazy, it's not funny. So I'm using my keyboard, so Control V and Control V. So now, when we play it, it should work, hopefully. Yay, and it does. Okay, but let's just say we've been playing around with the code and we want to change that back to timer. And now it won't work because timer is now associated with timer spawn. But what we can do is just delete spawn. So now that is, actually it's got a lowercase t. So we've got to change that to a lowercase there. And that, so we just change that to that. And bang, we are good to go. Okay, so referencing scenes and objects by referencing variables is a really great way to make sure that you can change things easier. So all I have to do is change that once rather than changing 1, 2, 3, 4 instances of it. Okay, 4 instances is not a big deal, but if you've got hundreds of instances, that is totally going to suck. Now the other way you can do this, instead of using get node, is by using the $, which is a new thing in Godot 3. Okay, so $, and I'm just going to change that back to a capital T for timer, only because, there we go. So, and as you can see, that has the same effect as that whole get node function. Okay, so what we want to do now though is we want to, just to add a bit more variety, we're going to go timer. No, we're not going to go timer at all. We're going to go enemy instance, speed, and we're going to set a random speed. So let's go random range. Now I've got no idea what our speed of our enemy actually was. So 0.5. Okay, so let's go 0.25 to 0.75. So this means that when the instance is created, we're going to assign it a variable speed between those two numbers there. So let's see how this works. And something didn't work. So what's that saying? Invalid set speed on base. Okay. Enemy instance. Okay, so what's that say? Invalid index speed. So why did I not call it speed on enemy? I did. Okay, well that's interesting, isn't it? Enemy instance. Did I do a spelling mistake? Okay, area type D value float. Maybe it's because it needs to be Control X. Maybe it needs to be up here. So no, still throwing an error. So let's have a look. Random range, enemy instance. So that's the enemy scene speed. Okay, I've got no idea why that's not working. So equals random range. Yeah. So this is a bit odd, isn't it? So enemy instance X, position X, enemy instance speed. So why, oh why is that one not working? Okay, yes. So sometimes probably what's happening is it's being instanced too fast. Okay, so what what I suspect is happening is that it's being instanced before it's actually loaded into the scene tree, which is going to make life very difficult. Okay, so there are a few ways to get around that, but probably the let's just see instance dot speed. Let's just see it's not something else. Equals 6. So let's just check. Yep. So yeah. Okay. So it doesn't on a base of enemy. What's going on here? So sprite, enemy, it's a sprite. Don't tell me I did this. Okay, so what I've actually made a complete dog's breakfast of this one. Okay. Big mistake I've done here. The mistake I've done is I've actually attached the script not to the parent, but I actually attached it to the sprite. Okay. So that's a big mistake, and so what we're going to have to do is we're going to go to script here, and we're going to clear the script, and then we're going to add this script where it should be. So to do that, we go to script here, and we're going to load up the script. So the script should work pretty much. Except it's called sprite now, isn't it? So what we're going to do is let's create a script. So we're going to create a script called enemy. So yeah, so basically, hopefully you guys didn't make that same mistake, but that was very silly of me. So let's open the script. Create. Now what we're going to do is we're going to take the script called sprite, and I'm just going to copy, so Control C into enemy. So let's just do this. Okay, and then what we're going to do is so we don't get messy, I'm going to right click the sprite script, which we don't need, and go delete. Okay, files, so that's in enemy, so I'm going to just click remove. Okay, so now it should work. So let's just close that one. So okay, so just to go through the mistake I did was the script, instead of attaching the script to this node here, I accidentally attached it to the sprite node. Okay, so it was trying to, so it basically created a speed on the sprite, and then when we instanced it, I was trying to access a variable on the enemy which actually had no script. So I've rectified that by creating a new script and copying the data there. So now this should work when we go in our spawner. Okay, so this should work. There we go. Okay, so now when we play, hopefully we don't get any more errors, because that was kind of embarrassing. So what should happen now is they should be being spawned at different speeds, and you can see that. See how this one's breaking away and it's probably going to catch up to that one. That one's going a bit faster. So we've got these different speed enemies falling down upon us. Okay. Rightio. So we've pretty much got the basics down pat now. So we've got our player, we can shoot, and we've got enemies to shoot at, but nothing actually happens. There's nothing's happening when we shoot, and that's because we need to set up some collisions. So remember when earlier when I said, oh well, let's set up the collisions later. That's what we're going to do now. We're also going to do something else as well. On the function ready, we are going to assign each thing to a group. Okay. I think it's add to groups or something. Add to group. So what this is saying is we're on the player, so we're going to add this to the group player, and what that means is that we can easily ask the question of any object, are you a player? Yes or no. So let's do the same thing for the projectile. So let's add to group projectile. So in that way we can say if we have any interactions with a projectile, are you a projectile? Yes or no. And let's do the same thing for enemy. So we're going to add the enemy to the enemy group. So we add to group enemy. Okay. So let's go ahead and get our enemy, and let's add a shape. Let's attach a child node, and we're going to attach a collision shape. Collision shape 2D. So again, we've got a bit of an error happening there, and it's saying that we need a shape. So to add a shape, we go here to our inspector. At the moment, the shape is empty, so let's add a new rectangle shape. Okay. Yep, rectangle shape should be fine. So if I'm going to zoom in here and see how there's that, it's going to be hard to see, but see how there's a little boxy, like a pale blue boxy thing there. That's the collision shape. So we're going to have to make that a bit bigger. So we drop down and we go to edit, and let's make it 32 by 32. So now the shape is covering that. Okay. So that's sort of kind of, so what that's saying is we can now monitor anything that's sort of happening in that area. Okay. So let's go back to our script. Actually, let's save things. Always a good idea to save, particularly when we've been doing a whole bunch of stuff like that. Okay, so what we're going to be doing now is, let's do the same thing for the projectile. Okay, so we will go to our projectile and we'll add a collision shape, and let's zoom in here. Now of course this is all going to be changed once we start putting other graphics assets in. We're going to have to change these, but this is just for the purposes, so we're doing exactly the same thing as we did before. So this is just for the purposes of play testing. 32. Okay, and enter. Whoops, I don't know what I did then. Okay, so let's now go back to our enemy. Okay, and we're going to go back to our enemy script, and we are going to see, actually let's see, I'm just checking my Discord, and no, nothing's happening there. Has anyone asked any questions? Nope, no questions so far. Okay, so we've been going for about 2 hours. So hopefully this is of some use. Hopefully this is some being of some use to you guys. So we're in our enemy, and what we're going to do is, remember how we connected up to the timer? We did a connection to a signal. We're going to basically do the same thing on this. We're going to connect. But what we're going to connect is what's called an area entered, because, oops, area entered, and it's right up the top there. So area entered. So what this is saying is we want to know when another area enters this area, and that's going to be really handy. So let's call it on area entered. On area entered. Okay. So that's the function that's going to be called. So when anything enters it, that's going to be the function that gets called. So let's create the function. Function. That was the wrong thing. So Control Y. It's me pushing the wrong buttons. So on area entered. Okay, and what we're going to have to do is, now on area entered actually requires an object. So this is the object which is being entered. Now again, this is not going to make much sense for the time being, but it will. So what that's saying is, if an area enters the enemy collision shape, go to this function here. Okay, so let's use our if statement that we learned the other day. So if the object, so we don't know what the object is, so the object is whatever enters the area. So if object is in the group of projectile, so what that's saying is, if the object's entering it, it belongs to the group projectiles, obviously a projectile, then what we want to do is we want to destroy, first of all, the object. So Q free. And we also want to destroy ourself. Q free. Okay, so let's have a look and see what happens when we run this. Okay, so now we're getting somewhere. So what's happening is we can now actually destroy the little ships coming down. But it's important, this is really quite important, because if we didn't have this, if we just had, if we weren't sort of saying, well, don't worry about the projectile, if we're saying if any area enters it, if we had the case where one spaceship catches up to another spaceship and passes it, then they would both be deleted. Okay, so that's quite kind of important. Now we can also, and we can, and then what we're going to probably do later on is we can add an animation for the explosion. So let's put a placeholder in. Consider adding an animation for explosion. So that's to make it look really cool later on, but we're not going to worry about that just for the time being. So if the object is in group player. Okay, so what are we going to do if it's in the group player? Now, the safest thing to do is to actually ask the player what it wants to do. Because who knows, the player might have a force shield on, it might be immune for a time being, like it might have like a immunity counter thing going on. So what we can do is we can actually access a method in the player. So let's go to our player script and let's have a script called hit. Okay, so if, no, function hit. Okay, so for the time being, all we're going to have is just something that will let us know that we've been hit. So we're going to print player hit. I was going to say spaceship hit, player hit, exclamation mark. Okay, so what we're going to do now is if the enemy touches the player, we are going to call the object, okay, and we're going to call the hit method. Okay, so what that's saying is that's if the object which is entering is in the group player, which as we've set it up must be the player, then call the object hit. Call that, sorry, not the object, call the method hit. Okay, so let's see how that works. Oops, that's me clicking on the wrong thing. Okay, so now when we get hit, what you'll notice is on this output screen, it should print player hit or ship hit or whatever we said. So let's just wait. See, there was an overlapping and it didn't, so okay, and it didn't hit. Okay, so why was that not called if the object was in the group player? So let's go to player, and the reason for that is we never assigned player a collision shape. So of course, because it didn't have a collision shape, it's not going to recognize any collision. So let's quickly add one there. So the shape will be is exactly what we did before. So I'm going to move pretty swiftly. Edit, let's say 32, 32. So now we've got the shape. So now it should work because it's actually got a shape for which it can recognize a collision. So again, that was a bit embarrassing on my behalf, wasn't it? Okay. So it's times like this, I wish they were moving a bit faster. So again, that collision would, so get ready, get ready, get ready, bang, players hit. So as soon as that one hit, touched the player, it triggered the player hit, the player hit function. Okay, too easy. So let's just review. I might call it a day here, but let's review what we've done so far. So we have created, what have we created? So we've created a player which can move left and right, and the player can fire, and when it fires it will spawn a projectile, and the projectile can go up, and if the projectile touches an enemy, the enemy will then be removed from the game. Enemies are spawned by a spawner, which will randomly spawn them on the y equals 0 value, but in a random position along the x-axis. And then we've created a a level node which contains a player and the spawner. Okay, so let me know in the comments if you have, if there's something that sort of I've missed or anything like that. If you've got any questions, if I went too fast, if I went too slow. And what we'll be doing is, in my next stream, I will source some graphics assets and we can look at making it look a little bit nicer, because remember the first byte is with the eye, and we can maybe add some animations and things like that. So let me know what you have thought about this, and I look forward to seeing you on the next stream.